Welcome back. Our previous video covered how we design choice experiments in a way that it will allow us to identify preferences for the attributes that we're interested in. And in today's video, we'll move from design to data and actually talk about how we would practically estimate the parameters that we're interested in. In this video, we'll focus on two different types of choice experiment: discrete choice, where the individual selects their chosen alternative, and rank ordered choice. The video after this will cover stated probabilistic choice. And we'll start by looking at how the data is structured after we collect it in the way that I described in the previous videos. This is an example data set from a discrete choice experiment, and it's got a particular structure that I wanted to highlight. First, we can see the decision maker identifying variable and the number of the scenario that they were offered. And each scenario has three options, and the respondent selects whichever one maximizes their utility. And then here we have one characteristic Z. Think of this like the price of the good or whatever else. And obviously we'll have many more of these, but the idea is that in this situation we have N times T times J rows of data, where N is the number of respondents, T is the number of scenarios, and J is the number of alternatives in each scenario. So we have this hierarchical data that will allow us to estimate preferences. So how do we estimate in this situation? Well, we just treat it like we would a logit that we've covered in the previous videos of this course. The Rust bus engine model was a panel data set where we saw Zurcher's decision whether to replace or keep driving the engine on each of the buses that he had stewardship over. And so every choice scenario is just another observation in that individual's panel. And then we sort of had it in the long panel data format just for convenience. It could equivalently be expressed in a wide panel format as well. Just depends on what software package we're using to estimate and how it requires things to be set up. We can also add preference heterogeneity through mixed logit. We can relax IIA by doing nested logit. We can do a multinomial logit if there's more than two options to choose, etc. So now what would it look like if we did a rank ordered logit? Here, instead of having a dummy for this was chosen, we have a dummy for the rank ordering. So person 1 in scenario 1 finds alternative A to be the most attractive. And so they put a rank of 1, and then 2 on C, 3 on B. And then we have the same Z variable here. This could be the price of the good or some other aspect. And we can define the rank as either ordinal or reverse ordinal, and we can always just redefine the rank to fit whatever the software package we're using requires. Now, to estimate the parameters of the rank ordered logit, we have to use what's called the exploded logit model, which comes from several decades ago. And namely, the likelihood needs to account for the fact that we have a particular ordering that can be thought of as the joint probability of a particular sequence of ranking. So that choice probability is going to look like a product of logits, but each successive term in the product conditions on one fewer alternative in the choice set. So if I want to know the probability that I ranked option 1 first all the way down to option cap J last, then I would say what's the probability that option 1 was ranked first out of all of them? Then what's the probability that option 2 was ranked next out of the rest of them that are still eligible to be ranked? So we're going from 2 to J here, and then so on all the way to cap J minus 1. And then we don't need to include cap J here because it's just exp of Zij gamma over exp of Zij gamma. It's 1. It cancels out. And if we want to, we can add mixing probabilities to get a mixed exploded logit. And I just want to make a note that this provides more information on preferences than just a 0-1 option. And so we actually know what the relative preferences are for all of the cap J minus 1 non-chosen options, which provides more information about how the decision maker values the different attributes of the choice scenario that we've provided. And I will say, kind of previewing a later video in this mini series, it's also possible when we have such detailed panel data to even relax some of the mixed logit assumptions and do things a little bit more non-parametrically. And so we'll talk about that down the line, and hopefully you'll see what I'm talking about when we get there. That's just a little taste of how to estimate these models that come from stated preference data. And in general, I think most practitioners will plug these into a regression type of package like R or Stata. They won't necessarily be deriving their own likelihoods for these. There are tried and true commands that can easily analyze this type of data. Our next video will get into how we do the estimation for the stated probabilistic choice experimental data. So I hope that you'll find that one valuable as well, and we'll also clarify some final details about how these three different models, the discrete choice, the rank ordered choice, and the stated probabilistic choice, all fit together, and how the stated probabilistic choice is the most detailed in terms of the amount of information you get about the preferences. So hopefully you'll join me in the next video, and thanks for joining this one.